Hey, math class. We're going to review a little bit with changing back and forth from mixed numbers to improper fractions. So here I have a mixed number 3 1/4, and if I want to make that into an improper fraction, so something with a number that's bigger on the top than on the bottom, the first thing that I'm going to do is to find my top number, which is really kind of easy. All you're going to do is say 3 times 4, which is 12, and add the top number, which is 13. Okay, so I end up with 13, and my bottom number stays the same, so it's just going to be 4. Okay? And so let me connect this to what we were talking about yesterday, too, with like pictures of things. Oh, I just messed my thingy up here. What that really means is that I have, so let me write our number again. It was 3 1/4. If I was going to find that, right, 3 1/4, what that means is that if I have these little shapes that have 4 pieces in each shape, I have 3 that are completely colored in. There's 1. Here's 2. Here's 3. And then in this last one, all I have is a fraction of it, right? I only have a part of them filled in. Only one of the 4 will be shaded in. So if you look at that, it's pretty easy to see. I have 1, 2, 3 whole shaded in objects, and then 1/4 over here. But if I were to count them individually, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Ah, look at that. 13 over 4. So do you see how they're sort of connected, how they're really connected? Let's review just a couple more times the process of finding them, but keep this picture in mind. That's what you're really doing. It's the same picture written 2 different ways. Okay, here's another problem. 7 4/5. That's my mixed number. I want to change this to an improper fraction. So again, 7 times 5, 35, plus 4, 39. Had to stop and think there for a second. And your bottom number stays the same. Just bring the 5 straight over. So again, if I were to draw this 7 4/5 out, it would look the same as 39/5. All shaded in as well. One more, just to review this. 10 3/8. So this is a bigger whole number, but we still solve it the same way. 10 times 8. And I'm going to write in, because sometimes I think it's good to sort of have a picture. I'm going to multiply. 10 times 8 is 80. I'm going to add the top number, which is 3, 83. Bottom number stays the same. Okay, so let's work it from the other side too. So here's an improper fraction, 5/2, right? So if I were to look at this picture, here I have some little shapes, some little objects that only have 2 pieces in them. I'm going to shade in 5 of these halves. 1, 2, 3, 4, 5. Right? So I could say this as 5/2, or I could say it as, well, here's a hole, and here's a hole, and then this is half of a hole. So I could say that that's also 2 halves. But let's do the math for it, and see if we come up with the same number. Okay, so if you remember back too, that this line means divide, we can keep that in mind too. What this really is 5 divided by 2. If you need help kind of figuring out like what am I supposed to do here? I'm having trouble remembering. Just remember that line means divide. Okay, 2 can go into 5 2 times. 2 times 2 is 4, and then I subtract and I have 1 left over. And then remember, usually we were going like that, right? But we're not going to do that anymore. But we are going to bring it up. And it becomes the top number of our fraction. And then whatever's on the bottom over here, that stays the same. And so our answer, let me write it down here closer, 2.5. So we did the math for it, and it matches our picture, 2.5. Okay? Let's review with a couple of other examples here, and we'll just do the math for these guys. Okay, 18/7. So if I did have a picture, I would have a bunch of objects made up of 7 pieces, and I would have as many as needed to be to color in 18 of them, and I could see my whole numbers that way. But again, remember 18 divided by 7, so I'm going to go 7 into 18. 7 can go into 18 2 times. 7 times 2 is 14. I'm going to subtract. I have 4 left over. So I bring my remainder up, only instead of writing remainder 4, I write him as the top number of my fraction. And remember that the denominator stays the same. So my answer here is 2 4/7. One other thing too, so let me kind of put some colors with this too. I know somebody mentioned that. I think that's a good idea. So if I come back over here, this 7, I'm going to make him red because he doesn't change from our problem, right? So our problem's written in red. I'll write him in red. And the 4, I'm going to make it green so that you can see where he came from. So he came from right here at the remainder spot. So hopefully that helps with that. Let's look at one last example here. 15/3. Okay, so again, if I had a picture of this, I would have a bunch of objects broken into 3 pieces each, and I'd have enough of them that I could shade in 15/3. 15 of those little third pieces of the objects. But let's do the math for it here, because remember 15 is divided by 3. 15, whoop, that 5 looks funny. 15 divided by 3. 3 can go into 15 5 times, which is 15. Ah, look at that. This is an interesting situation, because all I have here is a whole number, right? I don't have a remainder. And so if I was writing a fraction, it would look really funny, because it would be like 5 0/3, and that just means that this guy doesn't exist really. So my answer to this is just 5. And so even though we're working with fractions, this would still be my answer, because 15 divided by 3 is a whole number, so it would just be a whole number without a fraction. So we're going to review some of this again tomorrow in class. It seemed to be a little fractured today, so we'll try and clear up any issues and talk about any other questions that you have. But hopefully this sort of makes more sense watching some more examples.